Welcome students to our new YouTube channel Pharma X Tech, the division of excellence. So let's start to the new chapter of modern pharmaceutics, which is suspension. So let's start to the suspension. So this is suspension, not your bike suspension, that means rear suspension. So we are a pharmacy student, so in the pharmacy there is also suspension, and we are not a engineering students. So these videos are for only for pharmacy students. So we see the pharmaceutical suspension. So in the first pharmaceutical suspension, we see the introduction towards the suspension and some basic important points. So the particle size ranges from 0.5 μm to 5 μm. That means the particle size are in the range of 0.5 micrometer to 5 micrometer. Then next, suspension display the thixotropic properties, that are they should be highly viscous at rest but they readily on shaking, and the light and lyophilic particles have tendency to clump together and float on the surface of the liquid, so wetting agent is added, and for examples are hydrophilic polymers such as sodium CMC, that means sodium carboxymethylene cellulose, and also water soluble materials such as bentonite, aluminium, magnesium silicate and colloidal silica. Alcohol, glycerol may also be used in the suspension. So in short, the suspension, we see the bottle of liquid dosage form, the particles which are suspended at the rest. So we shake the bottle, then suspended particles float to the surface. So there is the direction in the bottle that shake well before use. So this direction is because of the suspended particles, and if you don't shake the bottle of liquid, then there is no phase separation between this bottle and the suspended particles not flow the upper surface, and thereby there is no such mixing of this liquid solution or the liquid bottle. So next we see the suspending agents. So the suspending agents are hydrophilic colloids. So the hydrophilic colloids impact viscosity to aqueous vehicles, and it requires addition of preservatives as they support the growth of microorganisms. And the hydrophilic colloids, for examples are acacia and tragacanth. And being compound tragacanth powders, these compound tragacanth powders are in that they contains powder tragacanth plus powder acacia plus starch plus sucrose, and quality of compound tragacanth powder per 100 ml of mixture may be up to 2 gram. And the other examples of these hydrophilic colloids are methyl cellulose, carboxymethyl cellulose, and these carboxymethyl cellulose, it is an anionic substance. So next is clays, and the example of clays are bentonite, vigum, and both are silicates and anionic aqueous dispersions. And also the suspending agents are soaps and emulsions. So and the examples are cetyl alcohol. This cetyl alcohol is an emulsion, is used as suspending agent for preparing only suspensions for topical use, that means for skin. And calamine lotion use soap emulsions as suspending agents. So this calamine lotion is used in the soap as emulsion and also as suspending agents. So the next suspending agent is dispersants. So these dispersants is to break the aggregation or avoid the formation of aggregation, and the example of these dispersants are polymerized organic salts of alkyl aryl type such as darins, daxars and marasperses. These are the dispersants, and the levitation. These levitation is the most common technique which is useful in reduction of particle size, and propylene glycol and as to glycerin are most commonly used as levigating agent. So in the GPAT here is a question that which are the levigating agents, and the right answer is propylene glycol and glycerin. So next we see the agglomeration of suspension is measured by the differential manometer. So there is a question in GPAT. The agglomeration of suspension is measured by which technique, and the right answer is differential manometer. So next we see the difference between the flocculated suspension and deploculated suspension. So in the flocculated suspension the particle exist as loose aggregates, and in deploculated suspension particles exist as separate entity. So in flocculated suspension particles are loose aggregates, and deploculated suspension the particles are separately entity, that means they found in separates. And in flocculated suspension the rate of sedimentation is high, and in deploculated suspension the rate of sedimentation is lower. And in flocculated suspension sediment form rapidly, and in deploculated suspension the sediment is formed very slowly, that means slowly. And the in flocculated suspension it consists of loosely packed particles possessing a scaffolding like structure. A hard dense cake does not form, and the sedimentation can easily redisperse. And in reverse, in deploculated suspension sediment becomes very closely packed as the repulsive forces between the particles are overcome. A hard cake is formed which is difficult to redisperse. And in flocculated suspension the elegant preparation are obtained due to the uniform distribution of loosely bonded flocks. So in flocculated suspension and the examples is we shake the bottle, there is the distribution is uniform distribution, then the bottle's liquid drug is mixed in uniform likewise. So in deploculated suspension unslightly the preparation result due to the formation of sedimentations. So next we see the flocculating agents. So these flocculating agents which promotes the flocculation by causing the colloids and other suspended particles in the liquid to aggregate the forming of flow, and the examples of flocculating agents are multivalent cations such as aluminium, iron, calcium and magnesium. So next is deploculating agents. These deploculating agents prevent the flocculation by reducing the viscosity and is called as dispersants. An agent for thinning the suspension of slurries. They are low molecular weight anionic polymers, and the examples of deplocculating agents are polyphosphates, the polyphosphates and lignosulfonates, the polyphosphates, lignosulfonates and water soluble synthetic polymers. So the deplocculating agents examples are polyphosphates, lignosulfonates and water soluble synthetic polymers. So next is the suspension stability. So this suspension stability is the most important for the suspension. So this suspension stability, the stability of suspension is a complex, and it is the balance between the flocculation and deflocculation, and is readily dispersed by small change in pH, temperature and electrolyte and also polymers concentration and the concentration of other additives such as flavoring and coloring agents. And these suspensions are adversely affected by both high and low temperatures. So these suspensions are adversely affected by both high and low temperatures. This is most important in suspension. And the fluctuation in temperature should be avoided, as this may accelerate crystal growth and they leads to the formation of increasingly large particles, and very small particles may dissolve more readily than large particles. So we see that in this bottle of liquid solution, there are very small particles. They are not seen by our naked eyes, and these small particles, they may dissolve more readily than large particles. So in this liquid bottle, the suspended particles at the bottom, they not be a large because they not disperse or they not dissolve more readily. So which particles are more readily to disperse? They are very small particles. They may dissolve more readily than the large particles in the solution, and in such instances the smaller particles will go into the solution and recrystallizes on the large particles. This causes the coarsening and the suspension, and it is known as the Ostwald ripening. So the suspension stability, this causes the coarsening of the suspension, and this coarsening of the suspension is known as the Ostwald ripening. So next we see the evolution of suspension stability. So in the evolution of suspension stability, it is the measurement of sedimentation volume as to sedimentation chemograph, and also rheological technique such as Brookfield viscometer and electrophoretic method such as zeta potential, and in that the particle size analysis. The methods of particle size analysis are by microscopic method and photographic technique are used in the evaluation of suspension stability. And also the miscellaneous techniques such as caking and flocculation phenomenon, and they include filtration rate, quantification of particles changes using the streaming current technique, and conductance studies. So the formula is F is equal to HU upon H naught. So in that HW is the ultimate height of sedimentation in deploculated suspension, and HU is the ultimate height of sedimentation in flocculated suspension, and H naught is the ultimate height, and Fw is equal to HW upon H naught, where Fw is the sedimentation volume of deploculated suspension and F is the sedimentation value of the flocculated suspension. So this is the equation which for the evaluation of suspension stability is the Fw is equal to HW upon H naught, and also F is equal to HU upon H naught. And at last we see the degree of flocculation. So the degree of flocculation is equal to beta is equal to F upon Fw, and is equal to HU upon H naught upon HW upon H naught is equal to HU upon HW. So in short, the degree of flocculation is the ratio of ultimate sedimentation volume of flocculated suspension upon, that means, to the ultimate sedimentation volume of deploculated suspension. So this degree of flocculation is the ultimate sedimentation volume of flocculated suspension upon the ultimate sedimentation volume of the deploculated suspension. So here are we completed some basic points in suspension. So in this suspension chapter, that means pharmaceutical suspension, we study the particle size range is the suspension is 0.5 micrometer to 5 micrometer, and the examples of light and lipophilic particles, examples are hydrophilic polymers such as sodium carboxymethyl cellulose. And next we see the suspending agents like hydrophilic colloids, Examples are acacia tragacanth, and other examples are methyl cellulose, carboxymethyl cellulose. It's an anionic. And then next clays. Examples are bentonite, vigum, and both are silicates and anionic aqueous dispersions. Then next we see the soaps and emulsions, and examples are cetyl alcohol and calamine lotion. And next we see the dispersants, and examples are polymerized organic salts of alkyl aryl type such as darians, daxars, and marasperses. Then next we see the levigating agents. They are propylene glycol and glycerin. So next we see the difference between flocculated suspension and deploculated suspension. Then next we see the flocculating agents. Examples of flocculating agents are multivalent cations such as aluminium, iron, calcium, or magnesium. Then next we see the deploculating agents. So the examples of deploculating agents are polyphosphate, lignosulfonates, and water soluble synthetic polymers. So at last we see the suspension stability and evolution of suspension stability and degree of flocculation. So here is the complete of this chapter, suspension, pharmaceutical suspension. So hope you like this video. Please, if you like this video, please share this video to more and more to your GPAT aspirants as well as CET aspirants too. And also like, share and subscribe to our channel. And thanks for watching this video, and stay connected with Pharma Extract. Thank you for watching. Stay tuned with Pharma Extract. Thank you. Welcome students to our new YouTube channel.